I'm gonna move the x over to the other side. So I would get negative 16y equals 16 minus x squared. And then I would want to do it. Good, divide by negative 16. Y squared equals 16 minus x squared over negative 16. And then the last step would be square rooting, making sure I do what with that square root? With the plus and the minus. Good so far. All right, so when you graph number 1, you get this picture, which is what shape? Hyperbola. So for a hyperbola, you want to identify the vertices, which are the point in which the direction changes, here and here. That'd be negative 4, 0, and 4, 0. And then identify which direction it opens. So is this a vertical or a horizontal hyperbola? Horizontal. Questions on that one? Mm-hmm.
Are we supposed to graph really calculate?
So for this, you had to. On the actual assignment, I'm going to give you a graph. Yeah.
How are we supposed to graph it?
You're going to learn that when we get to the hyperbola section.
Oh,
So there's a...
we don't have to do it.
Not yet. Yeah. Nope. You're going to eventually learn how to graph each one. There's a section for each of the conics in which you'll learn how to do them by hand for each one. Isabel. Horizontal means like that they literally open along the horizontal axis. So a vertical hyperbola would look like this. They face up and down, right? And a horizontal is going to face right and left.
And also, how do you know if it's a hyperbola or a parabola?
So parabola will only be one curve,
Oh, okay.
where the hyperbola is going to be 2.
Wait, how did your hyperbola open this way? Mine opened that way.
All right, so then number 2, I want to subtract the 4x squared, and then divide both sides by 49, and then square root. So plus or minus the square root of 196 minus 4x squared over 49. All right, this is 2. So what kind of graph is this? An ellipse, good. So with an ellipse, you're going to identify the intercepts, which are at positive 7 and negative 7, so negative 7, 0, and positive 7, 0 are your x-intercepts. And then your y-intercepts, which are at positive 2 and negative 2. So 0, 2, and 0, negative 2 are your y-intercepts. And the center, which is right in the middle there at the origin, or 0, 0. So for a hyperbola and a parabola, you're going to say the type, the vertices, what direction it faces. For an ellipse and a circle, you get the center and the intercepts. Questions on that one? Okay, so this one, divide by 6, y squared would equal x over 6, and then square root. So y would equal plus and minus the square root of x over 6. And then graph it. Okay, this is the graph of this one, which is what shape? Parabola. So the vertex, which is the point in which the direction changes, which is 0, 0. And does this open upward, downward, left, or right? So faces right or opens right. Either one of those is fine. And the last one, subtract the x squared and then square root. So y would equal plus or minus the square root of 0.25 minus x squared. All right, and then here is my last one, and this is what shape? It's a circle. Here, I'll zoom in on it so you can see a little bit better. Okay, this is a circle. The center is here, which is at 0, 0. And this looks like if this is negative 1 and this is positive 1, that might be a little bit less than a half. We can approximate it at about a half. So it would be 1/2, 0, and negative 1/2, 0 for the x-intercepts. And then same for the y-intercepts. So I could have gotten an exact point on those if I had traced the graph, but we can approximate them a little bit. you're going to find out exactly how to get those centers and the radius when we start this next section. Questions on any of those four? So are you able to solve an equation for y? And are you able to, given a graph, tell me what kind it is and give me information about it? If it's a center or an ellipse, can you give me the center and the intercepts? And if it's a parabola or a hyperbola, can you give me the vertex or vertices and the direction it faces? Does everybody feel confident? Questions? Okay, everything up. All right, so number 5 on the warm-up is finding the center and the radius of a circle that has the diameter with the endpoint. So this kind of directly leads into the next section, which is circles. So if you want a visual, you could plot it. Okay, endpoints at 3, 7 would be over 3. 1, 2, 3 up. 1, 2, 3, 4, 5, 6, 7. Here's one endpoint, and then -2. 1, 2, 3, 4, 5 is the other endpoint. So this would be my diameter. And my circle would wrap around, something like that. Okay, so the first thing it says to do is find the center. So how do I find the center given the points? Good. The midpoint formula is going to give me the center because I want to know the point midway between these two endpoints. So I add the two x's, 3 plus -2 divided by 2, and add the two y's, 7 plus -5 divided by 2. So 1/2, 2 over 2, which is 1/2 and 1. That's the center of this circle. And then it says to find the radius. And there was 2 ways. You remember who can give me one way to find the length of the radius? Do the distance formula on what? Because there's 2 different ones you could do. Okay, distance formula on the endpoints and then divide by 2, right? Because the endpoints would be your diameter. Divide it by 2 to get the radius. That's one way. What's the other way? Good. Center to one of the endpoints. So the fact that there's a half there, I would try to avoid that one. If it was a whole number, it's faster to do it that way. But if it's not, then you probably want to do the diameter and divide by 2, which is what I'm going to do. So I'm going to use the distance formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. Using these 2 points. So square root of the x2, which is -2 minus 3 squared, plus -5 minus 7 squared. Square root of -5 squared plus -12 squared, 25 plus 144, 169, which is 13, and then that's the diameter, so divide it by 2 to get the radius. Questions on that one? Because again, now the whole section we're talking about in 12.2 is all circles. So we go all circles 12.2, we go all ellipses 12.3, we go all hyperbolas 12.4, and all parabolas 12.5. So you go individually into each one. We're going to learn how to graph these by hand and learn all the ways to graph them without having that graphing calculator do it for you. So it's a different. All right, so 12.2 is called circles. A circle is defined as a set of points in a plane that is a fixed distance from fixed points. And the fixed distance is what we know as the radius, and the fixed point, the one in the middle, is what we know as the center. Okay, so some just vocab there. Obviously, we know center, and the distance from that center to all of the edges of the circle would be the radius, or radii, which is plural. So one way you could find the formula of or the equation of a circle is using the distance formula. Because all of the points on the circle are the same distance from the center of the circle, I could have taken the points that are on that circle, plugged them in as the x and the y, found the diameter, okay, and that should be radius squared. You gotta know that. And then you would have gotten the equation. It's a much easier way to do it. I'm going to show you a much easier way to do it in just a second, okay? But remember that the distance formula is x2 minus x1 squared plus y2 minus y1 squared, which is what we just used. So this is where the actual equation came from, which is what I'm about to show you. Okay, so use the distance formula with x2 and x1 being as x and y, and x1 and y1 being as 4 and 2. and the distance equal to the radius, which is 7. So I'm going to plug this in to that distance formula as x2 minus x1 squared plus y2 minus y1 squared equals the distance. And it wants you to use this point as your x1, y1, and it wants you to use the radius as the distance. So I get the square root of, and use x and y as your 2's. So x minus 4 squared plus y minus 2 squared equals 7. Now the only real thing I can do with this is get rid of that square root. So how do I get rid of a square root? I square both sides. So the square on this side and the square on this side gives me x minus 4 squared plus y minus 2 squared equals 49. And that's what the equation of a circle is going to look like. So the equation that you'll use is that x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared. And they'll refer to these points as HK. So if your center is HK, it's x minus h squared plus y minus k squared equals the radius squared. So the circle is pretty easy. All you have to do is plug in the center and the radius. When you plug in the center, it's going to change the sign. So if that was a positive 3 as my center, it becomes x minus 3. If it was a negative 3, it becomes x plus 3. And then the radius, all I have to do is square it. So we're going to start to blend these together. The ellipses, the hyperbolas, the circles, the parabolas. What you want to pay attention to is eventually when we get to the end, you should be able to look at the equation and know what kind of conic it is. So a circle is going to have an x squared and a y squared with a plus in between them. Okay, that's one thing that you'll learn. And then the distance from the center to each side is going to be the same because obviously you want that perfect shape. So when we get into ellipses, you'll see how it will change, how it will look different. Yep.
From chapter 6, you know how we were like graphing different kinds of lines on the same grid?
The piecewise functions?
Piecewise functions. Are we going to have to do that with this?
No. The piecewise function will come back on your test, but not with circles.
Oh.
Yeah. All right, so this is kind of what we just talked about, and here's like a little bit of a visual for you. So the equation of the circle with center HK and radius R is x minus h squared plus y minus k squared equals r squared. So if my center was 5, negative 2, then I would get x minus 5 plus y minus a negative 2 equals 8 squared, which becomes x minus 5 squared plus y plus 2 squared equals 64. So the signs will always change when you plug them in. And then the graph would look just like that. You'd plot a point at the center, and then I'd count up, left, down, and right, 8 units, and connect my points. And then that bottom part just says, if the center of the circle is at the origin, then the equation simplifies to x squared plus y squared equals r squared. In other words, you don't need to write it as x minus 0 squared plus y minus 0 squared equals whatever the radius is squared. That should simplify to get rid of your zeros, and then you would write it like this with a number in the place of the r squared. Ian?
We can't simplify that to x plus y equals r. By
No, you would, because they're not. X is squared by itself and y is squared by itself. It's just like combining like terms. They wouldn't be like terms. Okay, write the equation of a circle with center 0, 6 and radius 2. So again, x minus h squared plus y minus k squared equals the radius squared. This is my h, this is my k, and this is my r. So x minus 0 squared plus y minus 6 squared equals 2 squared. And then just simplify it. So x squared plus y minus 6 squared equals 4. So you won't ever, well, you won't need to for the standard equation, expand that y minus 6 and then FOIL it out. You'll keep it exactly the way that it is. Okay, this one's a little different. It says, write the equation of a circle with a center of negative 4, 11, and containing the point 5, negative 1. So if you wanted to get a visual on this, this would be center at negative 4, 1, 2, 3, 4, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my center is all the way up here, and I have a point at 1, 2, 3, 4, 5, negative 1, which means my circle goes around it like that. So a that's a really lovely circle, but you get the point, okay? So containing the point means that the actual rim of the circle or the outer edge of the circle would go through that point. So if I need the center and the radius of a circle in order to plug it into the equation, what am I missing? I have the center, right? So I'm missing the radius. How do I find the radius? Good. So the distance formula from the center to the point it contains. So I know my center already, negative 4, 11. And the radius is going to be the square root of, and it doesn't matter which ones you use as the x1, y1, or the x2, y2. It doesn't matter. So let's say that this is my x1, y1, this is my x2, y2. I'd get 5 minus a negative 4, which becomes positive 4. Negative 1 minus 11. 9 squared plus negative 12 squared. Square root of 81 plus 144. Square root of 225. So I could go through the work of square rooting 225. Does anybody know what that is? 15. Okay, but what am I going to do when I plug it back in? I square it. So you don't have to go through that work, right? Like whatever it is underneath that radical is going to be what's in your equation. So you could walk through that step. If it said identify the radius, then you'd have to. But if you're just using it to plug it back in, then I get x minus a negative 4, because that's my center, plus y minus 11 squared equals the radius squared, which is 225. Ian?
Why is it 5 plus 4 and a 5 minus?
Because the 4, I know I wrote on top of it, but the 4 is negative. So it would be 5 minus a negative 4, which would have become positive.